Math 2, Unit 8, Lesson 5. We're talking about inscribed angles. So if you look on page 509, this is a very important theorem, and you're going to need to know this for the final and obviously for Unit 8. So what it's saying here is that whatever the angle is here, so angle B, whatever that angle is, this outside one right here is double that. So that would be 2x. Okay, and it goes back and forth. So whatever this is, you cut it in half to get the inside angle. Okay, does that make sense? Now, when we were doing in the previous lesson, or back in like 8.1, they had a circle where you had the center and you had an angle going from the center. Do you guys remember that? And these angles, the angle here and the angle on the outside were the same. So do you see how this one is not at the center? It's on the outside of the circle. And so this one, this angle, the arc is double whatever the angle is. Okay? So when it's from the center, they're the same. But when it's from the outside of the circle, they're either half of each other or double each other, whichever way you're going. All right.
Don't do it.
Okay, I'll wait. So if this was 5, the arc would be 10. But on this one, if this was 5, the arc would be 5. Okay. Can I change it yet? All right. Okay. Moving on to page 510. Okay, so what do you think measure angle A equals? $90 is correct. What else is something that we notice about this diagram? How much would this whole arc be?
180.
Good, 180 because it is half. And how do you know for sure it's half? The line in the middle is going through it's going through the center, right? And so we know that each of these halves are 180. Okay, we're gonna move on to this next one. Okay. So this is where I think sometimes it gets a little bit challenging. You have to I sometimes mark things with a pencil and then we'll go back and erase them. So do you see here how this 106, it's from this point to this point, okay? So do you see how if you were to add all the way around here, it should all add to be 360. Do you guys agree with that? Okay, so how do you think we could find what measure angle A is? Does anybody have any ideas? So based on the information that I told you before, do you see how A going to the arcs, and this is what I mean where I will like erase things? The A for arc is from this point all the way to this point. Do you guys see that? So if we're going from the arc outside, so I'm going to do measure angle A equals, and how much is this whole arc? 190. What do I need to do in order to just get A? What do I do with the 190? Divide it by 2. So remember that the arc length is double. So if we want to get to the angle, we have to take the arc length and divide it by 2. And so 190 divided by 2 is what? 95 is correct. Good. Okay, so then this is why I will go back and erase this. So now when I go to do measure angle B, excuse me, So do you see how B, it goes from here to here? Do you guys see that? So you go the angle and you draw those lines, okay? And so what is the arc for measure angle B? 154. So how do I find the angle? Divide it by 2, which equals, you might want a calculator, it makes things easier. 77 is correct, good. Okay, so then again, see how like using a pencil can be helpful on this, because then I'm going to go back and erase it. And now I need to look at C. So C, see how from here the line goes out this way, and then it goes this way. So what is the arc length for measure angle C? Good, 170, and so we take 170, we divide it by 2, and we get, very good. And then our last one. So we have measure angle D. So from D, if you draw the lines from there, how much is that? Good. 206, and then we take 206 and we divide it by 2, and we get, good. Okay, any questions? Is that okay with everybody how we've done that? Yes? Okay. C, it says, what do you notice about the sums of the measures of the opposite angles? So opposite angles are B and D. So if you were to add B and D together, what do they equal? 180. So I'm just going to write here. B plus D equals 180. Okay, what happens with A and C? 180. So what do we know about those angles then? They are supplementary, because remember, supplementary means that they equal 180 degrees. So when you have this quadrilateral inscribed in the circle, your opposite angles are supplementary. Okay? Are we good? Okay. Moving on. Page 511. Okay, practice problem number 1. Okay, so it says find the value of each variable for each circle. The dot represents the center. Okay, so I'm not going to tell you how to do this, but I just want to reevaluate what we know. So we know that the outside of all circles has how many degrees? 360, okay? And so what they're asking here is find how much this arc is. Well, once you know how much this arc is, what would you do to get angle B? Exactly, divide it by 2. So I'm going to give you just a couple minutes here to get those 2 answers for A and B. You can talk in your groups about it. If you get the answer, raise your hand, and I will check it. Okay, the 218 is right. Okay. That you divided by 2. Half of 218. Oh wait, let's have the 18. That's great. But what's it going to do for me? So do you oops, I'm sorry. Okay. Did you get it? Yeah. There we go. Okay. No. Yes for A. Yes. yes on that one. This is correct for A. And this is correct for B. Okay. So, in order to get the value for A, since we know the whole circle is 360, you have to add the two pieces that you know together and subtract it from 360. So 82 plus 60 is how much? 142. So I'm going to take 360 minus 142, and we end up getting what? 218. So that means A right here, this equals 218. Okay, so that's the measure of arc A equals 218. Okay, now in order to get measure of angle B, we have to take our arc length, which is 218, and divide that by 2, which makes 109 degrees. So your answers should have been 218 and 109. Okay, do we have any questions there? All right, let's move on to 2. 2 is slightly more complicated, so I kind of want to work through this one together. So first of all, I noticed that I need to find A, B, and C. So most of the time, I'm just going to write over here, measure angle A equals, B equals, and C equals, because sometimes I don't always find them in order. So let's look at A. If you look at A, we're trying to find this angle. Do we have that arc? Yeah, what is the arc for A? If you notice, see how A, and again, this is why I kind of use a pencil, or maybe you can use a highlighter. If I draw that out, it's 108. Good. And so in order to find what A is, what would I do? So we would take 108 and divide it by 2, and so A equals what? 54. Are we okay? All right, so now let's look at B. And if I go, the line's going from angle B, do I have that arc? Yes, so what will I do? Good, which is 30. Now, if I look at C, it's not going from the center, it's not going from the side, so I can't use what I've been using in order to find C. Does anybody have any idea on how we could find C? What do you think, Francisco?
For the triangle that has A and B in it, since the triangle adds up to 180 degrees, you could subtract both 54 and 30 from 180 to find C because of the vertical angles.
Very good. That was perfect. So this angle right here is a vertical angle with this angle right here. And since we now know that this A right here is 54, and we know this B right there is 30, we can add those and subtract it from 180 to find this angle, which will be the same as C. Okay? So 54 plus 30 is how much? 84, right? And so then we take every triangle has 180 degrees, so we go 180 minus 84, and then we get the answer of 96. So measure angle C is 96 degrees. Okay, any questions on that problem? So you see how you have to kind of like, sometimes when you look at it as a whole, it can seem complex, but if you go through and look at the individual pieces of it, it's not as bad. Okay? All right, moving on. We're still on page 511, but we want to look at this next theorem-ish thing here. So here on this one, which is important, it says that, do you see how A and B share the same arc right here? Okay. So if they're inscribed in this circle, okay, and these points share the same arc, these angles will be the same or congruent. Okay? So again, if you have this little figure in here, if these 2 points are on the same arc, which they are, these angles will end up being the same value. Okay? We kind of already did a problem with this, But an angle inscribed in a semicircle is a right angle. So anytime you have it going through your center, this ends up making a right angle. And then we talked about this already, but if you have a quadrilateral, your opposite angles will always be supplementary. Okay? And again, this has to be where the figure is inscribed, meaning it's touching the sides of the circle. Okay. So on got it problem number 2, and this moves on to page 512. It says in the diagram to the right, what is the measure of each numbered angle? So again, sometimes looking at the whole thing can seem overwhelming, okay? But we're going to go ahead and write down, we need to find measure angle 1, measure angle 2, measure angle 3, measure angle 4. Okay, we do not have to go in order. So I want you guys to look at this, and based on the information they gave here, there are some angles that are kind of easy to find. Good, 1 and 3. Do you guys see how 1 and 3 end up making, so if you were to draw this as a line right here, do you see how you have a triangle inscribed here and a triangle inscribed here, which means that angle 1 has to be what? 90, and angle 3 also has to be 90. So those ones were pretty easy. Okay, so now what could we do? Okay, so what are we going to do with 4? Very good. So do you see how 4 right here, if we draw our lines to go out, it has this whole arc, which includes 60 and 80. Do you guys see that? And so for 4, we're going to add 60 plus 80, which equals 140. And we divide that by 2, which makes, good. Okay? Now for angle 2. How could we figure out angle 2? There's actually a couple different ways. Wait, say that one more time.
90 plus 35, which is half of 70, and then subtract that from 180. It's a 4-sided.
The only thing though is that, okay, so right here, this is 90, right? There's another way that I think, or maybe this is what you're saying. So what did we talk about these angles? They are what? Christian, what did you think the answer for 2 is?
For 2, 55.
Okay, so you need to double it because you're only doing half of 2
Oh,
when you did that. Okay?
Yeah.
Kyle.
I added 60 and 8 to get 140, and then subtracted 360 from that to get like the outside of the circle.
Good. Okay, so 360 minus that ends up giving you what? Did you?
220.
Okay. So Kyle was like, okay, this part of the circle over here was 60 and 80, so this whole arc over here has to be 220 because the whole circle is 360. And then 220 divided by 2 equals 110. Okay? That is one way of doing it. Francisca, how'd you do it?
In a circle like that, the opposites are supplementary, so 4 and 2 are supplementary. So what I did was I got 180 and subtracted 70.
Exactly. So that's the other way you could do it. So we know that, remember that opposite angles, those add to be 180. And so since we already know that 4 over here is 70, that means that 2 has to be 110 because it's the 2 add to be 180. So another way was to do 180 minus 70 to get 110. And do you see how it doesn't matter which way you do it, you're going to get the same answer either way? Okay? And then the way that Christian did it is he just took this as a triangle. Okay? And so he took, let's say, like the top triangle right here, and he found that he got 55 for this piece of 2, and then he just had to double it to get the whole 2. Right? Good. Okay. Do we have questions before we move on? What's another way, Matt? Good. Perfect. That is another way. I didn't even think about that one. So we know that a quadrilateral has 360 degrees. So since we knew this was 90 and this was 90 and the other one was 70, you add those up and subtract from 360 to get that missing piece of the quadrilateral. Good, thank you.
Good job.
Okay, moving on to page 5. Oh, we're still on 512. Number 3. Okay, so basically, you guys, I feel like these problems are kind of like puzzles. So you just have to use your brain a little bit because you have to think. But we know that there's 2 things we have to find on this one, and what is that? X and Y. So measure angle X and measure angle Y. Now, do you notice anything about X and Y? They're going to end up being the same. How do you know that they're going to end up being the same? Because they're sharing that same arc, right? And so since they're in the inscribed circle, that means X and Y will end up having the same angle. Okay, is there a way of me finding out what either X or Y is? How? Good. So if we were to draw these lines out here from X, do you see how it makes the arc of 72? So for X, we're just going to go 72 divided by 2, which is 36 degrees. Now, we know that these are the same, so Y is also 36 degrees. But if you were to draw your line here from Y and see how it goes here and here, do you see how it also is on the 72 arc? That's why they end up being the same. Okay? So again, Y, we can do 72 divided by 2, which is 36. All right. You guys ready for 4? Okay. Number 4, we need to find the measure of arc A. We need to find the measure of angle B, and then the measure of angle C. Okay, so which one do you want to start with? A? How do we find A? Very good. So since we have the angle here, in order to get the arc, we have to double it. So 25 times 2 means that our arc is how much? 50 degrees. Good. Okay, so now how can I find either B or C? Which one do we want to look at? Okay, C, and what do you think C is? 90. How? Good. Do you guys see how this goes through the center of the circle? And so we know that this ends up making a 90 degree. Also, if you notice, if you were to draw this out, see how it's half of a circle? And half of 180 makes 90. So it even makes sense as to why using the arcs. Okay, what do you notice about B? It's the same thing. Do you guys see how on B, it also is going through that center here? And so this angle right here is also going to be 90 degrees. Oops. Okay, questions about that before we move on? Another thing too is if you notice how these B and C share the same arc, they should be congruent. B and C should be the same. Okay, page 513. Okay, so Theorem 87 says that the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. Basically, it's exactly the same as what we've already been doing. This time, though, it's not going through the center. A chord is a line that doesn't go through the center. So this B to C is a chord. And then do you see how this one is a tangent line where it's just touching the circle at one point? So it's the same idea where this angle right here, we would give that the value of x, and then the arc would end up being 2x. So it's the same idea as we've been working, except for it's not going through the center, per se. Okay? So, should we go ahead and move on to A? All right. So still on page 513, got it, problem A. It says in the diagram at the right, KJ is tangent. So it's telling you that this line right here is a tangent line. And it says what are the values of x and then also y. So, if we're trying to find the angle of x, what do you think we could do? So, do you see how you have a chord here in the tangent line? Yes? We have, this is called a chord, this line right here. And then this line over here is your tangent. So x is like that angle inside there. So if I knew how much the arc was there, I could find the angle. Is there any way of finding how much the arc is? Do you see how 35 here is going here and here? So this arc right here is 35 times 2, which makes the arc 70. So then that means that measure angle x is actually 70 divided by 2, which is 35. Okay, now here is y. Now in order to find y, you need a little bit more information. Does anybody see anything? What do you see, Matt?
Since it's passing through the middle, that is a 90-degree angle. So you can add 90 and 35 and subtract it by 180 to get the...
That's right. There's another way of doing this one too. Anybody else see another way?
And you know that's 70, so because it's a 180 line, you just subtract 20 from 70.
Very good. So another way is, see how this is a half circle? Okay, and Jordan said this portion, this arc is 70, so that means this arc over here would have to be 110 because they have to add to be 180. And so then we would know that angle y is 110 divided by 2, which makes 55. So both ways you can get the same answer. Okay, so in parts A, an inscribed angle Q and an angle formed by a tangent chord, angle KJL, the intercepted arcs are the same. What is always true of these angles? And that is that they are congruent. Okay? So like this angle right here and this angle right here, they will always end up being congruent. Okay, page 513, number 5. Let's see if you guys can figure this one out on your own. Number 5. So you're finding this arc, y, and the angle x that's right here. And it might be easier to first find y and then find x. But not necessarily. There's lots of ways of doing it. Yes. This is right. Good. Check with who. Oh wait, I didn't put it. Yes. That's right.
I would think like trying to improve on is a
Good.
big deal. Here.
All right.
I really don't think it's
You're on your way. Yep, exactly. Get it? So how many degrees are in the circle? 360. So if you know that the whole arc is 230. You're talking about yeah. Good. So then now that you know that, how do you find x?
Yeah, like
Yes, you do. So remember the arc is the big part, and then what is, we've been doing something with the big part in order to get the small part.
I should have already had my license.
That's it. Okay, so your two answers should have been 130 and 65. So we know all circles have 360 degrees. So in order to find y, all we're doing is taking 360 minus 230, and you end up getting 130 degrees. if this right here is 130, in order to get that angle inside, all we do is take 130, divide it by 2 to get 65 degrees. Okay? All right, number 6. Okay, so this one we're just working the opposite way, correct? Or actually, you don't need, there's another way of figuring this one out too. So I'm just going to give you less than a minute, and I'm not going to walk around. Okay, so can I take a volunteer? You're not done yet? Okay, I'll wait. I'm sorry. I feel like Kate, they'll just yell at me.
I know. I'm not even done.
You want to help me, Joseph? Okay, what do you got?
I don't know if this is right, but I took 115, subtracted it from 180 to get E.
That is another way of doing this. Good. So hold on one second. Measure angle E, you took 180, subtracted 115. And why did you know you could do that? Yeah, because they're supplementary. It's a straight line. Very good. And when you did that, you ended up getting? 65 degrees is correct for measure angle E. And so then measure of arc F will end up being what? 65 times 2, good, which gives you your 130. Okay, did anybody do this different than Joseph? Because there's another way. Nobody else did it different?
We all know he did it.
Huh.
Did he do it like the angle 115 times 2?
No, he didn't. Okay, so Connor did it different. Okay, so Connor, he knew that this angle is 115. So to get this arc right here, all he had to do was take 115 and multiply it by 2, which made it this 230. Then he found that F was 360 minus 230, which is 130. So he found F of 130, and then did you take 130 and divide it by 2 in order to get E of 65? So either method works. Okay? Any questions? All right, last couple problems on page 514. We're just going to do 7, 8, and 9, but they're actually pretty quick. Okay, so number 7. What arc does angle A intercept? Remember, use 3 letters. Okay, so let's try again for some of you. So here is angle A, right? So what arc is it with? DCB, or you could say that as BCD, either way. So it's arc BCD, or we can say it as DCB. Both mean the same thing. Okay? Then it says, which angle intercepts arc ABC?
ABC. Nope, just kidding. DAC.
Okay, if you said D, you're correct. So do you see how you have arc ABC right here? So that arc goes with angle
Oh, you just
D.
use 1 letter?
Yes, for the angles 1 letter, for the arcs 3 letters. Okay? And then the last one, number 9, which angles of quadrilateral ABCD are supplementary? So which ones can you add to make them supplementary? Good. Angle A and angle C, right? Because they're diagonal opposites. And angle B and angle D. Any questions?